Okay, welcome back to our another video. So, this week we will be revisiting our solution to the problem we solved the other day, and we used a method that was totally reliant on intuition. Right, so our intuition told us that the 0, 2 was the points that the line y equals x plus 2 was tangent to the circle right over here. But today we're going to use a more algebraic way that doesn't involve guessing. So same as before, we will be using the equation of a circle. But this time, we are not going to assume anything. So we're not going to assume that the intersection point is at 0, 2. So how are we going to do that? Well, okay. So where we're going to do this, we're going to redraw our diagram. So we have our, let's draw our grid here. Great, so, and here's our point 3, 2 again. 3, 3, 2 again. And we don't know where the circle is or how big the circle is, but we have our let's let this point be 0, 2. Now we're not assuming anything here, right? Because this is just for the graph, and this is, and we're going to okay, great. Okay, nice. And then we're gonna draw our graph of y equals x plus 2. Remember that 0, 2 is the y-intercept of y equals x plus 2. So that's the we have made no assumptions so far that this is the intersection points. And now we just need to determine where the intersection point is. So actually, in fact, let's just delete. Let's get rid of the line. Yeah, that's good. So say we have a circle, right? Let's say that it's somewhere here. Actually, let's redraw that. Alright, okay, obviously this is a really bad circle, but okay, we're just gonna draw this circle right here. Okay, we're going to assume some point, okay, some point, x comma y. We don't know what it is yet. And okay, in fact, let's just make it over here. We don't know where it is. It could be any point. It might also be the y-intercept. So, and we know that the line must be perpendicular, must be tangent to the circle at that point. Therefore, the circle must be touching at only one point. So, in fact, let's just draw a second circle. And then this is our line, and then our center. And we want the line to be touching the point out, this one point. And what's special about the tangent point is that if we draw the radius, this is the radius of the circle, this line must be perpendicular to the tangent line. So how are we going to use this fact? Well, notice the line the radius forms. That's the line we're going to use that line to construct a second line. Okay, that doesn't make any sense, but this is going to be some other equation, which is in the form of y equals ax. Actually, yeah, wait, y equals mx plus b. This is some line, equation of a line that is perpendicular. That intersects y equals x plus 2 at at 90 degrees. So how will we find this line? Well, to do that, we need to know a rule for these two lines. So for a line, for any line, okay, there's only one line, so let's, for the line perpendicular to y equals x plus 2, the slope equals negative 1 over n. The slope is negative 1 over 1, which is negative 1. Essentially, it's the negative inverse. The slope of the perpendicular line must be the negative inverse of the line of your original line. In this case, it's negative 1. So now we can use our point slope formula. Which is given by m times y minus y1 is equal to m x minus x1. And we will use this formula to determine the equation of the line of this perpendicular line here, of the orange perpendicular line. And to do that, we need one point that is on the line and the slope. Alright, now I know what the slope is. What's the point? Well, we know that it's 3 comma negative 1, because it lies directly on the point, on the line. So it would be negative 1. So go to, the slope is negative 1. So negative x minus 3. And simplifying the equation, we have x is equal, y is equal to y plus 1 is equal to negative x plus 3. Distribute the negative. And y is equal to negative x minus plus 2. And that is our equation of the slope. So now we can figure out the intersection point. And you know that's when the two equations are equal. So therefore x plus 2 is equal to negative x plus 2. And simplifying, we get 2x equals 0. Right, subtract 2 on both sides. And therefore, x is equal to 0. The x coordinate is equal to 0. And therefore, let's substitute that into 2, and y is equal to 2. And the rest is honestly the same. It's the same thing as what we did over here. This is an algebraic way to determine the point of intersection.